All right, so here we go for predicting chemical products of a chemical reaction. So we're going to expand on what we did for our last test. On the last test, I gave you an acid plus a base yields a salt plus water. And we just kind of memorized, but we did follow a pattern. For example, if I have HCl plus barium hydroxide, we learned that this is called a neutralization reaction. And what we did was we followed a general formula. And that general formula was you take the metal from the base, the anion or the negative ion from the acid, and you combine them to make a formula. But the positive one always goes first. And so we have Ba with Cl. We got to do the charges. So we get BaCl2. And then what's left over is H goes with OH. And HOH is rewritten as water, H2O. So then we would balance the chemical reaction. But that's called a neutralization reaction. And like I said, we really just memorized. In a way, we memorized. But we started following what happens when you start rearranging things. Breaking the bond here, breaking the bond here, and then reforming it on the other side. And so that's what this is all about. And it is following general formulas. So we're going to predict the chemical properties, or the chemical products of a chemical reaction. And we're going to go over three types first. They're called synthesis, single replacement, and double replacement. And that's where I'm going to start. Now, most chemistry books are just going to give you, general formulas for these. But, back when I started doing this, I had only PowerPoint. And so I used to do it on my television screen, so I had to make these things gigantic so you could see it. And I used the clip art from PowerPoint. Well, actually, when I first started doing it, I did stick figures, the extent of my drawing artistic ability. But then after that, when I did PowerPoint, I had to find figures that sort of fit into my analogy. And my analogy is you're at a dance. And at this dance, boys can dance with girls, girls can dance with boys, but they can't dance boys, boys, or girls, girls. You just, if you do, my analogy doesn't work. So it's more like middle school, you stay divided, boys on one side, girls on the other. And then when you go to dance, you can only have a boy dancing with a girl, and you can't, have boys dancing with boys and girls dancing with girls. Well, our analogy here then is positive ions and negative ions. And so that's where it comes from, because you can't have two positive ions together, like charges will repel. You can't have two negative ions together. You have to have a positive and a negative. So here it goes. So here's my first two. I'll pause for dramatic effect. There's my first two figures that I could find in PowerPoint. So we have our skeleton. He represents our boy. We have our hula girl representing our girl. And this is the first type of chemical reaction that we are going to predict the product for. Now, when you see a single character, that means you have a single element. So this might be an aluminum plus, let's say, a nitrogen. Now remember, nitrogen is a Hofbrinkel, though. So that's really still a single element. So we have a single element plus a single element. Or, Mg plus S, for example. A single element plus a single element. Well, when you have a boy and a girl trying to go dance, you end up with a happy couple dancing. Remember, we always put the positive ion, known as the cation, first. The negative ion, known as the anion, second. And we write the chemical formula. Look how nice their hands even meet. So it's called a synthesis. It is also known as a combination reaction. So synthesis or combination, you have an element plus an element yields a compound. So now that's what you're going to find in a chemistry book. Not exciting. So A plus B yields AB. Now what we're assuming here is that A is the positive ion and B is the negative ion. And I can tell that because of the A being first. But remember, over here they are free elements. And free elements are by themselves, and remember, free elements have a charge of 0. So if they are a Hofbrinkel, then there will be two of them. If not, then they're just single elements. So hydrogen, oxygen, fluorine, bromine, iodine, nitrogen, and chlorine. All right, now this also could be B plus A yields. Now, if A is the positive one, you are still going to yield AB. So the order here doesn't determine the order over here. The order over here is determined, again, by the charge, and the charge being positive first. All right, so an example. Mg plus O2 yields. So we have an element by itself plus an element by itself. What you do is you put them together, and then you do the charges. This is a +2, that's a -2, and so we cross those, and the correct formula is going to be MgO. Now, why not carry the 2 over? Well, this 2 is here because it's an element by itself, and it's a Hofsprinkle. And that element by itself, but it's not. So now we would have to balance it. A 2 there and a 2 there would balance the reaction. Next one. Once again, an element by itself and an element by itself. You squash them together, and you do the charges. +1, -1. So that's it. A 2 there and a 2 there is once again going to balance this whole thing. Why don't you try one here and sort of just jumping right along. Let's say we have iodine and aluminum. So why don't you pause? I'll give you a chance to come up here and have someone come up and press the pause button. Give you a minute or two and predict the product. All right, so Al is going to go first. Why? It's the positive one. Iodine is going to go second, negative. +3 -1, so you should get Ali3. So we have a 2 there, and a 3 there to balance it. All right, so now we go into the next type of reaction. The next type of reaction, we have to introduce another character. We have our drunken dancing Santa. But he is going to represent a positive ion again, a positive ion. He's the boy. So we go boy. And over here we have boy, girl. So remember our rules. The boys can't dance with the boys. And so when Santa goes and tries to break into our happy couple, he's going to knock the skeleton out of the way and dance with the hula girl. Can you believe this is chemistry class? All right, so then if you're going to predict the products of that reaction, it's going to end up like this. So now you have the skeleton off by himself. Once again, a person by themselves is representing a free element. And now you have a positive and negative ion in a chemical formula. All right, so the chemistry way to put it would be A, element by itself, plus BC, where this goes positive, negative. A knocks B out of the way, and you get A with C. And now you get B off by itself as a free element. Now I have if A is a positive ion. Now remember here it's going to have a charge of 0. But when it forms an ion, it is going to form a positive ion. And so it knocks the other positive ion out of the way. So an example, Al plus NaCl. So Al, element by itself, it's going to knock the Na out of the way. So aluminum replaces sodium. And you get Al with Cl. And now you get Na off by itself. So now you have to reevaluate these. Every time you rewrite them, you must reevaluate them. This is a +3, and that's a -1. And so you get AlCl3. Na is not one of the 7 Hofsprinkle elements, so it's just Na. Some of you did that wrong in your quiz. This does not get a 3 subscript because it's a +3, because here it's a free element, and its charge is 0. All right, so from there, again, we would always remember you have to balance the reaction. So 3 Cl's, 3 Nas. And the reaction is balanced. All right, what about this one? So we have Ag. It's going to knock Fe out of the way. And you get Ag with NO3. Notice I'm eliminating the parentheses 2. That's there because of the charge of Fe. It's no longer with Fe. Now it's with Ag, which is a +1 charge. So +1 -1, and you get the correct formula for silver nitrate. And then Fe off by itself, not a Hofsprinkle element, therefore just Fe. All right, again, we have to balance it. A 2 there balances the nitrates, a 2 there balances the silvers, and we are balanced. So once again, we have to redo the charges. Remember, you're breaking the bond, separating them. So the charges are like so. And now silver is going to knock iron out of the way and become the positive ion. And then Fe goes off by itself, which again makes it a free element, charge of 0. Why don't you try this one? Once again, you can hit pause. I'll pause for a second so that you can do that, and then I'll give you the answer. All right, so we're going to have calcium knock potassium out of the way. You get Ca with PO4. And you get K off by itself. Notice I'm not carrying the 3 over, but I am carrying the 4 over. That's because this is the polyatomic ion phosphate. So it's still the polyatomic ion phosphate, but I have to do the charges, which is calcium's a +2 and phosphate is a -3. So Ca3, PO4 parentheses 2. And K goes off by itself, free element, no charge. All right, so I need to balance this. It looks like I'm going to need a 2 there to balance the phosphates, a 6 and a 3, and we are balanced. All right, so that's a single replacement reaction. Now that is if a boy wanted to break into a boy-girl dance partnership. But what if this was a girl? Remember our rules. You can't have boys dancing with boys. You can't have girls dancing with girls. And so now we need another character. Remember, PowerPoint didn't have very many back in 1996. So we have our beautiful ballet dancer. So now we have the girl going to try to break into our happy couple. She can't replace Santa. Our drunken Santa is going to hold on tight. But our girl ballet dancer will replace our girl hula girl. And then you end up, again, free element and a positive and negative compound. And so the general form, now we introduce another letter. We're not going to use the same one because A represented a positive ion, so now D is going to represent a negative ion, not over here because this is a free element, 0 charge, but over here when it forms the positive-negative ionic compound, when it does the replacing. So D replaces C, and C goes off by itself. All right, so an example of that. O2. O2 right there is a charge of 0, but it is going to have a charge of -2 when it forms an ion. And so you have O replacing Cl, and you get Ca with O, and you get Cl off by itself. Notice I'm not carrying the 2's over because this 2 is here because of the calcium. It's no longer with calcium, it's by itself. And this 2 is here because it's a Hofbrinkel. So now we must reevaluate that over here. Calcium is a +2 charge. Oxygen is a -2 charge, and so CaO is the right formula, but chlorine is one of the 7 Hofbrinkel elements. So a 2 there balances the oxygens, balances the calciums, and balances the chlorines. Let's do that again. Actually, I have that you try this one. So let me pause and see what you can do, and I'll be back. All right, so iodine is going to form what charge when it forms an ion? And that would be a -1. So it has to replace the negative sulfur. So lithium goes with iodine, positive, negative. And then sulfur off by itself, free element, not a Hofbrinkel, so just S, +1, -1. So that's the correct formula for lithium iodide. And then I need a 2 in front so that I can balance the equation with the 2 Li's and I's on the other side. So that's a single replacement reaction. I didn't mention that before, but it is called a single replacement, also known as a single displacement. Just depends on the book. So you're only replacing one element at a time. So now the last of the ones we're going to study today is called a double replacement reaction. So in a double replacement reaction, all 4 of our characters are back. And we have boy, girl, boy, girl. So we have boy dancing with girl. We have a boy dancing with a girl. So now in a double replacement reaction, also known as a double displacement, you have switching partners. So if Skeletor here is with the hula girl and our drunken Santa is with our ballet dancer in the beginning, kind of like square dancing, do-si-do, they switch partners. And it doesn't matter whether you look at it as the girl switching partners or the boy switching partners. Essentially, it goes like this. Positive, negative yields positive, negative, positive, negative. So the positives and the negatives switch partners, the general form being this. Now, oftentimes you'll see this as BC in a textbook. I just think that's wrong. They may do it because they have editors and they want to make things alphabetical, but A and C are the positive ions over here. And so if you go positive, negative, you should be going positive, negative, so that would be okay, but positive, negative in terms of the ionic substances. So I think it's better with AD plus CB, not BC. All right. So our attempt at this. All right, so we're going to switch. I usually look at it as just switching the first elements. So Fe is now going to go with S, but you could look at it as NO3 is switching too. You're going to end up with the same thing, just in the other order. I'll do them both. So Fe goes with S. Ag goes with NO3. So we have Fe with S, Ag with NO3. We have to redo the charges. Notice I'm not carrying the parentheses 2 over. That's because it was with Fe. It's not with Fe anymore. Now it's with Ag, and Ag is a +1. Nitrate's a -1, so that's good. Fe is a +2. Now you have more than one charge for Fe, but it's not going to change charge. So it was a +2 here, so it's going to be a +2. S is a -2, so you have +2, -2, +1, -1. So those are the correct formulas. If you looked at it as the negative switching partners, you would have had Ag goes with NO3 and Fe goes with S, but you can see it's the same thing, just reversed. And both of those are okay. They're both correct. Now to balance this, I'm going to need a 2 in front of the silver nitrate, and that balances the whole thing. If you did it there, it would give you that. And like I said, that's exactly the same. So why don't you try one? We've now done synthesis. We've done single replacement. So you can come up and pause again. So double replacement is still just switching partners, changing places. Okay, so copper, again, I like to look at it as the first ones are changing. You can look at it as the second one. Does not matter. So Mg goes with SO4, magnesium with sulfate, and you get copper with iodine. Copper in this case is a +1 charge, because there's no parentheses 2, 3, 4, whatever, and copper can be a 1 or a 2. So that's correct. Mg is a +2, SO4 is a -2, so that's correct. So we didn't have to do any parentheses or any crossing again. Probably a bad choice on my part. All right, so that's good, that's good. And again, you could have it the other order, CUI first, Mg, SO4 second. But I do need a 2 there to balance the whole thing, and I got it correct. All right, so why don't you pause here and try these. And then after a few minutes, when you feel like you're ready, you can push play and get the answers. Okay, so here we go. So Cl2 would be chlorine, free element, plus Fe2O3, the formula for iron 3 oxide, binary. All right, so I have to evaluate, is chlorine going to knock Fe out of the way or O? Well, chlorine right there is a free element, 0 charge, but when it forms an ion, it forms a negative ion, -1. So chlorine is going to knock oxygen out of the way, and it's going to go with Fe. Notice I'm not carrying the subscripts over because, they were for different reasons. A Hofbrinkel element here, and crossing the charges there. So here, now I'm going to have FeCl3 plus 3 minus 1. Oxygen by itself is a Hofbrinkel element. So O2. So now it looks like I'm going to need a 2 there, a 4 here, a 6 here, and a 3 here, and it is balanced. So that is a single replacement reaction. A single replacement where a free element replaces one of the elements in a compound. The next one, silver iodide, oxygen, Hofbrinkel, yields, oxygen, free element, 0 charge, but it is going to form a -2 ion. So it's going to knock iodine out of the way. You're going to end up with +1 minus 2, and then iodine by itself, which is a Hofbrinkel element. So a 2 there, a 4 here, and a 2 there, and this is also a single replacement reaction. Nitrogen plus zinc yields. Now this is a synthesis reaction where you have an element, free element, plus a free element. It yields a compound. The positive one must go first, which in this case is zinc. -3, +2. So you get Zn3N2, and a 3 in front of the zinc will balance it. And the next one. So we have lead-2 chlorate, PbClO3 plus Na, sodium yields. Single replacement. Sodium is going to form a +1 charge when it forms an ion. Right now it's a free element, so it's going to knock lead out of the way. And you're going to get Na with ClO3, and you're going to get Pb off by itself. +1 minus 1, 0. Looks like I put a 2 there and a 2 there, and I am balanced. The next one, this would be a double replacement reaction where we have a positive, negative, silver carbonate plus lead-4 chloride yields. You're going to get lead carbonate. I'll do those in a second. Silver chloride. +1, -1, but this is +4 minus 2. So when we cross those, you're going to get a 2 and a 4, which reduces to a 1 and a 2. Tricky there. Say that again. +4 minus 2, you would put a 2 there and a 4 there, which would reduce to a 1 and a 2. All right, so to balance this one, I need 4 chlorines, 2 silvers. That gives me 2 carbonates, and I'm balanced. And the last one is another single replacement. Barium plus cobalt-3 nitrate yields. Barium is going to form a +2 charge, so it's going to knock cobalt off by itself. And barium nitrate, BaNO3 parentheses 2. So then I'm going to need a 3 and a 2 to balance those, a 2 and a 3 to balance those. So there it is. There is predicting products of a chemical reaction. We've done the first 3 types of reactions: synthesis, also known as combination, single replacement, and double replacement, also known as single or double displacement. So try your homework. I will have the answers to that tomorrow. I will go over each one. And good luck. Write down any questions you have. If you have to send me an email, do so. I'll be checking it. Like I said, good luck.